Hi there, my name is Shri, and I've been working on a game on the side really called Triangle for a little while, and I've shared a little bit of an intro of that in another video. But before I moved forward with that, I wanted to do a small little game, Pong, just because it's something that most of us know about, and it should be hopefully fairly quick to do, just to get through that first part of Raylib setup and basic game development. I'll then carry on with Triangle. I don't know how far I will do Pong. I know there are some details which maybe or maybe won't bother about, like how it matters where on the paddle the ball hits, and then it goes in a slightly different direction. We'll see how I get on. So to start with, we're just going to, if we have a screen, we just need a couple of paddles, which we'll just place around there, and another one over here, and then we'll have a ball. Let me see if I can find a circle in the middle. I think, can I make it a real circle? That'll do for now. And I think in the original one, there was a line down the middle. Yeah, that feels about right. And we'll have a score over here. And we'll have, maybe make that a bit bigger. And put one on the other side. And that'll maybe be the playground. I think the ball just goes in one direction to start off with, and then you can ping it about. To start with, let's so I've got Zig. Actually, let's see. I've got Raylib Zig here. And what I need to do is there was something in the README. I just need to remind myself how there is a script. Actually, there's a script right here. Project setup. That might just tell us. Yep. So project setup. We're calling it Pong. Okay, so now we've got Pong. Let me just move this into, actually let's go into words on sand, creative games, and we dot slash. Where are we copying it from? Raylib Zig / Pong games. I have a blog site and I have a repo where I have all of my projects and, well, all of my public projects and the blog itself stored, and that's just called Words on Sand. I use Bazel because I'm used to it from working elsewhere, but I won't be using it for this one. I will link it up with it later. I just like to be able to run tests across the repo so that if I make a change to Zig, for example, and upgrade it, then I find it much easier to be able to test everything in one go. But let's just go into games / Pong, and let me just add everything in. That's fine. Actually, before I do that, just create a branch. Now let me commit. Let me just stash everything that we don't need. Okay, so let me just see if this actually works. It'll take a minute, well, hopefully not a minute, to load everything and run it. Oh, well, that's less good. Right. I think I know why this is broken. Pretty sure it's DevBox to blame. Let me just oops. Words on Sand, games, Pong. Let's try again. There we go. Easy peasy. This is just the default Raylib app that it creates for you. You could also just do Zig Init and add the stuff into the build.zig. It's largely 6.5 dozen, but this is what I did last time, so that's just why I did it again. Now let's start with main.zig. All we're really doing here is we have a window title, target FPS, and nothing super interesting. The first thing that we do want to change is the color. Let's I'll just check that that works. There we go. All sorted. Now, the next part that we want to work on is we want to create a new file. Let's start with a paddle. Std equals now in Triangle, what I did do is I created a facade called canvas, and I put all the Raylib calls behind that. It was just a way to tidy some of the bits up. Don't think I'll do that for this one. So for a paddle, there are a few bits that we need to know. There are obviously two paddles, and they both need to behave slightly differently. The basic functionality is the same. We check if the ball has collided with it, and then it'll let it bounce. But the collision itself, we need to check on different sides. So for the left paddle, we need to check the left side, whether it has collided. And for the right paddle, sorry, for the left paddle, we need to check if it bounced on the right side. And for the other one, we need to check if it bounced on the left side. We need to think about how we're going to check some of those things. We also need to show it a little to the left on here, and a little to the right for the left paddle, and a little to the left for the right paddle. So in any case, what we need are a few parameters. We need an x, which Raylib normally uses the top left as the starting point, but that's fine. X is a f32, y f32, and both the width and the height can be constants because they're not going to change. Let's go with 50, and const h equals 150. We need a render, so pub pub fn render. We need self. We need to be rendering the current one. So const, let's just call this paddle equals at this. I should say that I've not done Zig in a couple of weeks, 2 or 3 weeks, so I'm a little bit rusty. So please bear with me. Paddle. And what we want to do is rl dot draw rectangle. Let's just check the Raylib draw rectangle. There are a few variants of this. We just want the cheat sheet. Draw rectangle. That one is possibly a little annoying because Raylib in Zig we have to have the exact same type, so we'd need to have a bunch of int float from int, which is just annoying to do. The vector2 might be the way to do it, but of course then we need a vector2. Let's just see. Maybe what I should do is I should have a pos rl dot vector2. That's better. Rl dot sorry, that's not what I mean. Self dot pos, and then maybe what we should have is a const size equals rl dot vector2. Okay, let me just check. Raylib Zig. Oh, I think I can just do it this way. Dot x equals 50, comma dot y equals 150. There we go. Oops. And then let's just double check. Draw rectangle. Which one was it? Draw rectangle V. Draw rectangle V. Self.pos. Size. Hold on, my autocomplete doesn't seem to be working. Probably because Zig is not able to run properly because of devbox. Again, Pong. Let's try that again. It should be giving me better autocompletes. Paddle. Okay. No, that's still not right. Expected return type. Yep, fine. Void. Oh yes, I forgot RL here. That's probably why. Raylib. Is that better? Now let's see if RL dot works. RL dot. Okay, that's better. So we are missing one parameter here actually. Let's just do comma dot white. We also, yeah, that's fine. Let's just to start off with, let's create 2 paddles. Left paddle equals const import paddle. Let's just import that, and then left paddle equals paddle dot pos equals dot. Oops. Oops. Dot x equals, let's say, how big is the canvas? So screen height is 450, so let's put it at 200 comma y. We actually don't care about the y. Oh no, we do. Oh no, wait, I'm getting confused. X is the one that we care about. Y is going to be changed by the paddle itself when it goes up and down. So maybe what we should do is we should have an init pop fn init. What do we need? We need the x f32, and then we're returning a paddle. And then what we can do is, oh wait, let me just finish this one. Return dot pause equals dot x equals x comma dot y equals, let's just pop it. Screen height is 450, so let's just pop it somewhere in the middle. What does it expected? Wait, that's the part. Okay, and then what we do here is paddle dot init, and we want this to be, let's say, 50. What we could actually do is we could do we want to do that? No, let's just try this one first. This should be, we'll start with the const because we don't need to change it just now, and then let's just render, let's do const right paddle equals paddle dot init. So screen width is 800, so let's just do screen width minus 50. Actually, what we can do is we can do paddle dot size. Oh no, it's not exported. I'm almost tempted. Let's do it this way. We'll just pass in the edge, and we'll let the paddle itself adjust it for its width. That means that we can adjust the width later. But how do we know whether it needs to go on the, whether it needs to add it or subtract it? Let's, sorry, change my mind. Let's just keep it simple for now, and we'll figure out the rest of it later. Left paddle dot render, right paddle dot render, and let's see if that does anything. There we go. Wait, why is this one so close to the edge and this one is so far? Oh, right, because it's not including the width of the paddle itself. So actually this one needs to be times 2. Oh, actually, what we, wait, we just needed half of that. Right, okay. So what we actually want to do is times 1.5, oops, 1.5, and here it will be 25, because 50 is too much. We only need half of it. And that'll look a bit better. There we go. Paddles are still too large. Maybe what we need to do is we need an orientation. Orient this one actually just needs to be either a -1 or a 1. We'll just use byte. Oh, sorry, U8. U8. Okay. Comma orient U8. So comma dot orient equals orient, and then what we're going to do is x is going to be plus x times size dot x divided by 2. But that's going to make it complicated for the left one. Sorry, for the right one. That is annoying. I wonder if we can do rect mode center. What was it? Raylib rectangle draw from center instead of top left. Let me just check. Set the origin coordinates to 0. Yeah. Oh, right, okay. Draw rectangle pro. This function, origin, rotation, color for the rectangle, rotation. Let's just check. Pro. Rectangle, origin, float, rotation. Right, that seems more hassle than it's worth. Let's do it manually for now. What we can do though is we can make this one public. Paddle dot size divided by 2 dot x divided by 2. Paddle dot size dot x times 1.5. Right, this one, just for the sake of it, let's make this times 0.5, and let's make it a little bit thinner, 25. It's too tall. Let's make it a little bit smaller, maybe 75, maybe half. That'll be fine. A little too small. Oops. Just right. All right. The next, let me just commit that. GIA/C GC add paddles. The next one is the ball. Let's do that. That one is actually easy. What should we call it? Should we call it the ball or the puck? Let's call it ball. Const std equals. Right. I know we're not actually using std, but I don't know. I just got into the habit of just doing it at the start. Import Raylib. Oops. Const ball equals that. This. Now, what do we need here? We need the position. So pos rl dot factor 2. We need radius f32, and we need the velocity as well. I don't think we need to worry about acceleration. So let's do val rl dot vector2. Do we need to init this? Probably not. I think the parameters are simple enough, but let's give default values. Let's start with, I don't know, 16, and val would be equals dot x equals 0, dot y equals 0. Okay, let's render it. Pub fn render. Oops, self ball void arrow dot draw circle. I think it's circle V. That will take a pause. R, and let's do white. Oops. Self dot. And then let's see if it works. It did not work because I didn't actually call it const ball. Oops. Ball equals import ball dot zig, and let's just do this here. Const ball equals ball dot pause equals dot x equals screen width divided by times 0.5 dot y equals screen height times 0.5. Oops. And then let's render it. Ball dot render. And now let's see if it shows up. There we go. Let me just get rid of that text. I don't mind that being there. I don't want the text getting in the way of the ball though. Good. We've now got the basics rendered. I think I'll call this this episode here. In the next one, we will give the ball some velocity so it moves, and then we'll see if we can get a bit of collision detection working for the two paddles. I will also have a think about whether there is a cleaner way to encapsulate the logic of the paddle. It really feels like it's tricky because one is on the left and one is on the right, and they work in opposite ways. And we've also got this thing here where here we need to shift it by different amounts. So I'll have a think about whether there's a way to simplify that. We'll see how it goes. I hope you've enjoyed this video, and I look forward to doing the next one soon. And I'll see you there.